Okay. So in today's workshop, we'll learn what is linear regression, what is logistic regression, and how does this work. Okay. Let me put it down in simple words. What is linear regression? Linear regression, it is a statistical method used to it is actually used to model the relation between a dependent variable and an independent variable. Okay, let me write it down and then I'll explain this in a very simple words. It is the statistical method used to model the relation between a dependent variable and one or more independent variable by fitting a straight line to the data. Okay, or explaining this in very simple words, it finds the here I explaining this in very words, it finds the best fitting line that represents how changes in the independent variable affects the dependent variable. So now here this is the definition of linear regression. It is the statistical method used to model relation between a dependent variable and one or more independent variable by by creating a straight line to the data. Okay, or keeping it very simple, it finds a best fitting line that represents how changes in the independent variable is going to affect the dependent variable. Let's see what does this mean. Now what we are going to do here, I'm going to have some data. Let's say that here I'm having experience of the person and then I have salary of the person. Okay. So now let's say that someone having 1 year of experience has 8 LPA salary. 2 years of experience has 10 LPA salary. 3 years means his salary is 12 LPA. Now 4 years means 14 LPA. 5 years means his salary is 16 LPA. And then 6 years experience, or let me just put it like this, 2.5 years means how much is the salary. Now for 1 year salary is 8 LPA, 2 years 10 LPA, 3 years 12, 4 years 14, 5 years 16 LPA. Now if the person having 2.5 years of experience, how much is his salary? Now you want to answer this question. Okay. In this kind of scenario, linear regression is going to help you. Let's see how it is going to work. How does this work? Let's see. So now here I'm going to create a line chart. So let's create a line chart. Now in this line chart, in x-axis, I'm going to have experience. I'll write it down. In x-axis, I'm having experience, 0 years, 1 year's experience, 2, 3, 4, 5, 5 years, 6 years. And in the y-axis, I'm going to have salary. Here, 8 years, 8 LPA, 10 LPA, 12, 14, and 16. Okay. So now, according to their years of experience, the person with 1 year experience has 8 LPA, right? I'm going to plot here. Person with 2 years has 10 LPA. So what I'm going to do, I'm going to plot here. Like this, 3 years 12 LPA, 4 years 14 LPA, and 5 years 16 LPA, like this. Okay. Now this is what is happening. Now we have a new question here, that there is this guy with 2.5 years of experience, and what is his salary? Okay. Now let's assume that here I'm going to create a line. This is going to be an average line. Okay. Here I will be creating a line. Let's say that. So now if you observe this, now there are, if you find out the average till here, the first person has 8 LPA, second person 10 LPA, third person 12, fourth person 14, fifth person 16. This divided by 5. This is 60 multiplied by 5. So now average is 12 LPA, right? So the average salary is 12 LPA. Let's assume that here I'm going to create a line. I'm going to create a line here. This is the average salary, 12 LPA. Okay. Now let's assume that this person 2.5 years experience. We want to know what is the salary of this person. For now, let's assume that his salary is the average. His salary is 12. His salary is 12 LPA. Okay. His salary is 12 LPA. Now let's say I have one more question, that what is the salary of the person whose experience is 6.5 years. Now here, according to this logic, his salary should also be 12 LPA, right? Now the person with 2.5 years and 6.5 years, both these people are having salary 12 LPA. Does this make any sense? Is this making any sense here? No, right? This is not making any sense. So now this is not the answer. So what we should do in this scenario only, we take the help of linear regression. Okay. This is where we take the help of linear regression, which does not just take the help of the average line, but it tries to rotate this line at certain angle. Okay. So now here I'm going to write starting point. Let me just write it down here. Now this linear regression, what it is going to do, it is going to create a line, but it is not going to be this average line. Okay, it is going to create a line with certain angle. So now the starting point will be C, and the angle it is going to create, it is going to be M. Okay, the angle which it is creating is going to be M. So now what I'm going to do, look at this. Here is the line for linear regression. Here, let me just get this. Okay, I'll keep this dark yellow. Here, what I'm going to do, I'm creating this line. Now, this is the line created by logistic regression, linear regression. Okay. Now, this angle you're seeing, right? This angle is called as M. And here the C is the starting point. So now here, if you observe this black line is the correct values. So now 1 year experience means 8 LPA, 2 years means 10 LPA, 3 years means 12, 4 years means 14, 5 years means 16. Okay. Now here this linear regression has created this line with certain angle. Do you think linear regression has predicted correctly? Do you think it is going to give us correct answers now? And equation of the line is y is equal to mx plus c. So now what I'm asking you here is c. Now here observe this. Okay. Now look at this. The salary of the first person. What is the salary of the first person? The salary of the first person is, the salary of the person with 1 year experience is 8 LPA, right? Here I'm going to write 8 LPA. Okay. The person with the person with 1 year of experience has salary 8 LPA. Okay. Now, let me just draw this black line. These are the actual, this is the actual salary. Okay. Now here, the salary of the first person is 8 LPA. But what is this linear regression telling? This is the actual salary of the first person. But what is this telling? It is predicting more than 8 LPA, right? Let's say the model is telling 11. Okay, here, but according to model, according to linear regression model, salary is 11 LPA. Do you think this linear regression model is predicting correctly here? No, right? Obviously, it is not predicting correctly. Okay, it is giving me wrong answers. So in this scenario, what we should do in this scenario, look at this. Now, here I'm going to write down. It is making a lot of errors. Here I'll put actual and model predicted. Okay. Actual is the first person has 8 LPA. Now the actual value is first person with 1 year experience has 8 LPA. But how much the model is predicting? The model is predicting 11. Okay. So now person with 2 years experience, how much salary does this person have? This person has 10 LPA, but model is predicting a lot more than this, right? Here it is 12.2. Now third person with 3 years experience has actual salary 12 LPA, but now the model is predicting 15. Okay. Now person with 4 years has 14 LPA, but the model is predicting 16. Okay. Person with 5 years has 16 LPA. Now the model is predicting 16.5. Okay. Right. So obviously here, if you observe, model is making errors, right? It is making mistakes. Okay. So now this difference you're seeing, right? This is the error. Okay. Here I'm going to put it down. Here there is an error. So now how do we calculate error? Actual is 8 minus predicted is 11 square. Okay. So how much is this? Minus 3 whole square is 9, right? Minus 3 whole square is 9. Now you must be thinking, why do we need to do square? Because we don't want the values in minus. Okay. So now second time, how much error it is making? 10 minus 12.2. It is 2.2 whole square is 4.24. Third time, 12 minus 15 whole square, it is minus 3 whole square 9. Next time it is 14 minus 16 whole square 4, and then 16 minus 16.5 whole square, it is 0.25. Okay. So now if you add all this, okay, so now these are the values. If you add all this, and then if you find out the average of this, how much are we going to get? Here it is 9. This is 4, 0.25. If we add all this, 9 plus 9, 18. 18 plus 4, 18 plus 4, 22. 26, 26.24. Okay, something. So here we are going to get average error is, here if I add all this, I'm going to get 26 point something, right? So now divided by how many values are there? 5. So here I'm going to get 5 point something. Okay, this much is the error. The average error is, let's put 5.4. This much is the error. Okay, so now our goal, here I'm going to write, our goal should be, our goal is, or here I'm going to write, to get the error as close to zero as possible. Okay, this is our goal. Our goal is to get the error as close to zero as possible. So now here what we should do in this case, now interesting thing, now what is going to happen? The model is going to draw a new line. Now the linear regression model Now the model is going to draw a new line. Let's say line 2. Okay. So now here, earlier the model has drawn this line with this angle. Obviously we are getting errors, right? Now what is going to happen? This linear regression model is going to draw a new line, and that new line is going to be shown with the help of this blue dots. Okay, let's create this using blue dots here. Let's say that I'm going to create like this. So now if you observe this time, what is happening? This linear regression model has created a new line, right? If you observe this new line, it is very close to the actual lines, right? This new line is very close to the actual values. This is what is happening here. Okay. Now here, now what is going to happen? Let's see. Now here I'll put experience. Now the actual values, let's say the actual value is y. And then what is the model saying? Model says, or prediction is y cap. Okay. So now the person with 1 year experience has 8 LPA. Let me just write it down here. Person with 1 year experience has 8 LPA. And now what the model is telling, now look at the blue line. Can you see it is very close to this black line? Now this time the model is telling that here it is 8.1 LPA. Now the person with 2 years has actual is 10 LPA. The model is telling 10.1. Okay. Now person with 3 years has actual is 12 LPA. The model is predicting 12.2. 4 years, it is 14 LPA. Model is predicting 14.1. Okay. And then 5 years of experience, actual is 16, model is telling 15.8. Okay. So now let's calculate the error. So now if you observe, it is clear that this time the error is very less compared to the previous one. Error is very less here. Can you see? Let's calculate the error now. So now in this, what is happening? Let's see how much error we are going to get. Here I'll put error. Okay. So now here actual is 8 and the model says 8.1 whole square. Okay. Here, and next is 10 minus 10.1 whole square, and then 12 minus 12.2 whole square, and then 14 minus 14.1 whole square, and then 16 minus 15.8 whole square. Okay. So now if you take a average of this, okay, if you calculate the total and then if you take out the average of this time the error is going to be just 0.02. So now according to the last line, according to this brown line, how much is the error? The error is 5.4. But when this linear regression model has created a new line, this time did you see how much is the error? It is only 0.02. So our goal is to get that error as close to 0 as possible. Okay. So line 1 error is 5.66 and line 2 error is 0.02. Okay. So here, which is the best fit line, line 1 or line 2? Which is the best fit line here? Exactly. Line 2 is the best fit line because obviously it is giving us less error, right? So line 2 is the best fit. So like this only. So like this, model will draw multiple lines. Okay, like this model is going to draw multiple lines. and the one which gives minimum error is considered the best fit line as the best fit line. Okay, this is what happens in linear regression. Okay, now the big question is how the model is drawing lines. How model draws lines? How is model drawing lines? Okay, so now here I told you, right, the equation of the line is y is equal to mx plus c. Here the equation of the line is y is equal to mx plus c. We know what is m. M is nothing but the angle, which is generated, and c is nothing but the starting point, and x is nothing but, any idea what is x? What is x in this? Here what we are trying to predict, we are trying to predict the salary, right? We are trying to predict the salary. So equation of the line is y is equal to mx plus c. We are trying to find out the salary, right? So here salary is equal to m into x is nothing but the experience plus c. Okay, this is x is nothing but experience in this. Okay, right? Tanish, I'm going to answer these questions at the end. Okay. So questions related to that, I'll take them at the end of the class. For now, let's focus on the topic. Okay. So now how is the model drawing lines? Okay. How it is finding M and C values. How it is finding M and C values. Okay. So now to answer these questions, there are two techniques. First one is ordinary least square method. Okay, also called as OLS. Okay, so now by default, sklearn uses this OLS method. Okay, and here directly M and C values are given to us. So now for M value, M is nothing but formula for the slope is, you're having a formula here, summation of x minus x bar, y minus y bar divided by summation of x minus x bar whole square. Okay, so don't worry by seeing this formula, don't think that this is complicated, this is actually very simple. So now you just need to understand what is this x, what is this x bar. Okay, here x bar is nothing but mean of x values. X value is nothing but here, see, now we should identify this salary based on the experience, right? So this salary column is y and experience is x column. Okay, so now this salary is dependent on this experience, right? So this is called as dependent column, and this experience is not dependent on this, so this is called as independent column. Okay, so now here salary is y and then experience is x in this. Okay, so now x is nothing but, it is the mean of x values. X means what? Independent column. And y bar means what? It is the mean of y values. Okay, it is the mean of y values, and m is nothing but the slope, okay, of the regression line, and x is nothing but individual values, and y is nothing but, it is the dependent values. Just give me 1 minute, you will be able to understand what is this. Now you must be thinking the equation of the line is y is equal to mx plus c. Fine, this is the formula for m. Now what is the formula for c? The formula for c is y bar minus m into x bar. Okay, so now m, first you will find out this m. Okay, the formula for m is this: y bar is nothing but mean of y values, x bar is nothing but mean of x values. Okay, now in this we are going to take one more data set and then calculate here y is equal to mx plus c. Right, so now let's say that the total bill, there are some people who went to the restaurant and then they have made some total bill and they are leaving some tip. Here I'm having tip amount. Okay, this is your dependent column. Now the tip of the person is dependent on the total bill. Okay, so now the person who has made total bill of 34 is leaving a tip of $5. The person making 108 total bill, he is leaving 17. Here if he is making 64, he is leaving a tip of 11. Okay, 88, 8, and then 99, 14, and then 51, 5. Now there is this person who is making a total bill of 40. How much tip he is leaving? We need to find that out. Okay, so now equation of the line is y is equal to mx plus c, right? Here total bill, we want to find out this total bill is equal to m into x. Here I'll put into m into x. What is this x? X is not, sorry, this is not total bill. We are trying to find tip amount, right? Here I'll put tip amount into x is nothing but this total bill plus c. Okay, so now let's find out this, how much is the tip amount. Okay, there is this person who has done there is this person who has done this much bill. Now how much tip he is leaving, we should find that out. Okay, so now what we need to do, first here you need to find out m value and x value, x and then c value. Okay, if you get all these values, then you will be getting this tip amount. So now what is the formula of m? It is summation of x minus x bar, right? X minus x bar multiplied by summation of x minus x bar multiplied by y minus y bar divided by summation of x minus x bar whole square. So from this formula, let's only calculate this x minus x bar. Here what I'm going to do, here I'm going to put only x minus x bar. Okay, so now here what is this x? As I told you, this total bill, it is independent column, right? This column is x. Okay, and what is x bar? X bar is nothing but the average of this. So if you calculate the average, how much are we going to get? If you see, if you calculate x bar average of this, you're going to get 74. Okay, if you add all these values, if you add all these values and divide it by 7, you are going to get this value 74. Okay, so here we are calculating x minus x bar. So here 34 minus 74, 34 minus 74, how much are we going to get? Minus 40. Next 108 minus 74, how much do we get? 34. Now next 64 minus 74, how much do we get? Minus 10. Next we are going to get 88 minus 74, we are going to get 14. Okay, now this minus 74 will get 25. Now this minus 74, we are going to get 23. Okay, this is x minus x bar. Like this, here we need to find out y minus y bar also. So here I'm going to write y minus y bar. Okay, y bar is nothing but, here it is the average of this. This is dependent column, right? This is your y. Okay, now we need to find out y minus y bar. If you add all this and divide by 7, how much are we going to get? We are going to get, here I'll write down y bar value is 10. You'll actually get 10 here. Okay, so 5 minus 10, here you're having this first value, 5 minus 10, is how much? It is minus 5. Next is 17. 17 minus 10. How much are we going to get? 7. Okay. Like this, if we keep doing 1, 18 minus 10, you'll get minus 2. Here, you're going to get 4. Here, you're going to get minus 5. Okay. Here we have calculated x minus x bar, y minus y bar. Okay. Now next, what we should do, here we should multiply x minus x bar and y minus y bar. That is what we should do, right? So let's do that here. If you multiply these two, here I'm going to put multiplication. If you multiply minus 40 multiplied by minus 5, how much do we get? We'll get 200. 34 multiplied by 7, how much do we get? We'll get 238. Okay, like this only. Here we are going to get the values minus 10, minus 28, and 100, and we are going to get 115. Okay, so now we have completed this part. Okay, we have completed this part. And next, what you need to do here, you're having summation, right? So now if you add all this, how much total you are going to get? If you add all this, you are going to get result. If you add all this, you are going to get 615. Okay. Here we have calculated this numerator. Numerator, how much we are getting? 615. Okay. Now we should calculate the denominator. Now calculating the denominator is pretty simple. What it is? X minus x bar whole square, right? It is just x minus x bar whole square. We have already calculated x minus x bar, right? We just need to calculate x minus x bar whole square. So now 40 minus 40 multiplied by minus 40 will get 1600. Now 34 multiplied by 34, we are going to get 1156. 10 multiplied by 10, we are going to get 100. And 14 multiplied by 14, we are going to get 196. 25 multiplied by 25, we are going to get 628. And then 23 multiplied by 23, we are going to get 529. Okay. And then here you are having summation. If you add all this, how much you are going to get? If you add all this, the result is going to be 4206. Okay. Now this is your numerator value and this is your denominator value. Okay. So now numerator is 615 and denominator value is 4206. Now this is your M. Okay, how much do we get if we divide 615 with 4206? How much are we going to get? Yeah, let's see the calculator. Six one five divided by 4206. We are going to get 0.146, right? Here we'll get 0. Sorry, 0.1462 something. Okay. So now this is your M value. So now if you want to find out here, if you want to find out how much is the tip amount, we needed M value and then we needed X value and C. Now out of this, we have calculated this M value and how much we are getting. Here we are getting 0.1462. Now we need to calculate this C. Now what is the C formula? C formula here is y bar minus M multiplied by X bar. Okay. And here, how much is y bar? Y bar is 10. How much is M value? M value is 0.1462 multiplied by X bar is 74. If you do this, how much are we getting? 10 minus 0.1462 multiplied by 74. How much do we get? C value is equal to. How much is this answer? Can you guys tell me? So first do this and then this. 10 minus 0. Here it should actually be exactly the answer is here. It should be minus 0.8205. This is the correct answer. Okay. So now here the equation of the line is y is equal to mx plus c. Y is equal to mx plus c. We have already calculated c value. We have already calculated m value. Okay. And this y is tip amount. And m value is how much? M value is 0.1462. Okay. And then what is x value? X value here is, now what we are trying to do in this, we are trying to find out the tip of this person. Now the question is, if he has done this much total bill, how much is the tip, right? So now x here is this total bill. Okay. So now we need to substitute in this. So now here x value is how much? X value is 40. Okay. And how much is C? C value is 0.8205. If you do this, how much are we going to get? 0.1462 multiplied by 40 minus 0.8 minus 0.8205. How much are we going to get? First do this, then this. Here you'll notice that exactly we are going to get here something like tip amount is going to be what is the tip amount? How much are we getting after this calculation? 5 point something. Okay, this is your tip amount. Okay, if the bill is, if the total bill is 40, then the tip amount is how much? It is 1 point, oh, sorry, it is 5.01. Okay, this is your tip amount. Okay, here this question mark is there, right? Here the answer is 5 point something. Okay, here if this is the total bill, then this much is your tip amount. Is this clear to everyone? Everyone has followed till here? So now let's say if the total bill is 20. Okay, if the total bill is 20, now how much is the tip amount? Here we need to substitute. Here in the X place, we need to put 20. Now how much is the tip amount? If he is doing $20 bill, how much tip he is giving? If you do this, quickly tell me the answer. Exactly, it is going to be 1.98. Okay, this is 1.98. This is how you're going to answer things. If the person is making $20 bill, he is giving tip approximately 1.98. Okay, this is how. linear regression works. Okay, this is how m value and c values are calculated. You just need to substitute that x value. Okay, so guys, what I'm going to do, I'm actually going to show you code. Okay, I'm actually going to show you how to write machine learning code for this. Okay, so let me actually show you a data set. I'll first explain you the data set and then we'll see how to write code for this. I'll be opening. Okay, are you guys able to see my screen? Okay. So now here you're looking at this data set. So now what is happening in this? Let's see. Here there is an advertisement going on. Okay, if the people are spending this much amount on TV advertising, okay, and if they are spending this much amount on radio advertisement and this much amount on newspaper advertisement, then they are making this much sales every day. Okay, so now look at the second column, sorry, second row. If they're spending this much amount on TV ad, this much on radio ad, this much on newspaper ads, every day they are generating this much sales. Okay, so now in this, tell me which is the dependent column and which are independent columns. Now if you observe, the sales is dependent on the advertisement amount spent on TV, radio, and newspaper, right? So here sales is the dependent column. Sales is dependent column. And now these three are not dependent on anything. So TV, radio, and newspaper, they are independent columns. Okay. And sales here is the dependent column. Okay. So now what we are going to do, we'll actually be writing code to create a machine learning model, and then we are going to make predictions. So for this, what I'm going to do here, I'm going to import some libraries, import pandas as PD, import numpy as np. Okay, I'm going to run this. First, what I should do, I should load that data set here into my Google Colab. So if you want to use that, I'll just click on files here. Machine learning data sets. Here, advertising. I'm going to load this. Okay, as soon as it is loaded to my Google Colab, what we should do, we should read what is there in this. For this, here I'm going to do pd.read underscore CSV. Okay, this pandas gives us a method read underscore CSV. Okay, so now using this method, you can read what data is there in this. I'll click on this one, copy path, and then click on this. As soon as I'm doing this, PD is not defined. Okay, yeah. Now I'm going to store this inside this variable df, and then df.head is going to give me the first 5 rows. And if you observe this unnamed column you're seeing, right? This is not important. So we are going to simply drop this column. How do we drop this column? Here, we are having a method called as df dot drop. We want to drop one column, columns equal to, I want to drop this unnamed column. I'll get this and I'm going to pass this here, and then in place equal to true. The reason I'm writing this is I want to make the changes permanent. So, okay, I think I've given extra space here. Okay, we have dropped that column. Let's see if that unnamed column is dropped. df dot head. Okay, now look at this unnamed column has been dropped. So now what we need to do, we need to check if there are any null values. Okay, how do we check that? So before we give our data to for model training, we need to check if there are any outliers, if there are any missing values. Okay, to check if there are any missing values, we need to do df dot is null dot sum. I'm going to run this. So now when I'm doing this here, this is telling me that there are no missing values. Okay, so now how do we detect outliers? One of the best way to detect outliers is using box plot. So here I'm going to use from matplotlib import pyplot as plt. Okay, so I'm going to use matplotlib to create box plots. Plt dot subplot 131. I want to put all these box plots at a time. So I want to create, first I want to create a box plot for this TV. So here I'm going to do df of TV. Okay, I'm going to run this. Sorry. Here it is throwing me error. Okay, I did not import cborn. Import cborn as SNS. So let's run this. Here, if you observe, I've created a box plot for TV. Now, if you see here, there are no outliers. Like this, I need to create a box plot for radio also. And then I want to create here, I need to give 1, 3, 2, which means that I want this box plot of TV first, and then box plot of radio second, and then box plot of newspaper third. So now if you notice, I'm not getting them properly. The reason I'm not getting them properly is I need to give a proper figure size. I'll do plt.figure fix size is equal to 30 x-axis, 60 30 is the width and 60 is the length, 6 is the length. Okay, sorry, here also here I should give this position 3. Okay, so now observe this. Here TV does not have any outliers and radio does not have any outliers, but if you observe this newspaper is having outliers. Okay, so now any idea how do we detect outliers? How should we detect outliers? Any idea? So now what is this telling here? This line you're seeing here, right? Here, let me just. This line you're seeing right here, this is upper limit. Okay, this line you're seeing, it is upper limit. And this line you're seeing, right, this is your lower limit. Okay, anything above the upper limit and anything below the lower limit are outliers. So now if you observe here, there is no data above the upper limit and lower limit. Here also there is no data above upper limit and lower limit. So now here the upper limit is somewhere close to 85 and lower limit is somewhere close to 0. But if you notice, there are some values above the upper limit also, right? So now it means that newspaper is having outliers. Okay. Any idea what is the formula for upper limit and lower limit? Guys, how to detect outliers? Very important interview question. This is asked a lot in the interview. How do we detect outliers? So now here, this point you're seeing, right? This point is the middle value. Okay. This point is the middle value. You can say median. Okay. And then here, this point you're seeing, right? And this point is Q1. And then this point is called as Q3. Okay. And then from here to here, this area is called as IQR. Okay. And then here, this is your upper limit and this is your lower limit. So what is the formula for upper limit? Very, very important interview question. Okay. Sales is dependent means sales value is dependent on other three columns. So now how do you get this lower limit? Here I'm going to write lower limit is equal to Q1 value minus 1.5 multiplied by IQR. Okay. And upper limit formula is Q3 plus 1.5 multiplied by IQR. And how are you going to get this IQR? What is the formula for this IQR? IQR is simply Q3 minus Q1. Okay, this is your IQR. Okay, so now first you will find out lower limit and then you'll find out upper limit. Okay, and anything other than any data less than this lower limit is considered as an outlier, and any data more than this upper limit is considered as an outlier. So if you're noticing here, so now here you're getting some values which is more than the upper limit, right? These are outliers. So now to remove the outliers, there are two techniques. Okay, to remove the outliers, there are two techniques. First is trimming. First is trimming technique. In this trimming technique, what you do, you completely delete these outliers. That is what happens in this trimming technique. And second technique is capping. In capping technique, what happens here? Let's say that you're having upper limit as 85. 85 is the upper limit, and this data point is, let's say, 105, and then this data point value is, let's say, 90. Now these two values are updated to 85. Now this upper limit 105, this value is updated to upper limit. This is changed to 85, and then this 90 is changed to 85. So now as soon as we have done this, what happens? You don't have any outliers. This is what happens in trimming technique, where you completely delete the outliers. In capping technique, you update the values with the upper limit. Okay, this is how you are going to fix the outliers. So for now, we are not going to focus on deleting the outliers. That we are going to see in some other session. We are just going to keep these outliers like this for now. Okay, I just wanted to show you guys what are outliers. Okay, how to detect outliers and what are the techniques which are there to remove the outliers. Okay, so now what is the next technique? Here in this, we have checked for missing values, and then we are checked for outliers. And then what is the next thing we are having? Next thing we are having is separate X and Y values. Okay, here these are independent columns. TV, radio, and newspaper are independent column, and the sales is the dependent column, right? You need to separate them. Okay, all the independent columns should be stored inside X. inside X, what I'm going to do here, I'm going to do df.drop columns is equal to sales. Now what I'm doing here, I'm dropping sales column. If I drop sales column, I will only be left with these three columns, right? So that I'm storing it inside X. I'll actually show you X dot head. Look at this. X dot head. Can you see only these three columns are stored inside X? Okay. And then inside Y, I'm going to store this dependent column. Inside Y, I'm going to store this sales column. So here I'm going to do df of sales. Okay. So let's check and see if that is happening. Y dot head. So look at this. Here we are having the sales column. Okay. So now what is the next step? Now what we need to do here in this, we have split the data. Okay. All these three columns we have stored inside X and this we have stored inside Y. Now you need to give this data for model training. So now in this also, what will you do? You will take 70% of the data and give it as a training data. Okay. So here, what I'm going to do here, from sklearn dot model selection, I'm going to import train test split. Okay. And then what I'm going to do in this, I'm going to take 70% of the data and I'm going to ask the model to learn from this. Okay. So what I'm telling is here, let's say I'm giving this data and I'm telling machine learning model, I'm giving this 7 rows. Okay. So let's say that we are only having 10 rows here. Okay. We don't have these after this 11 you're seeing, right? We don't have all that. Let's assume that we are only having 10 rows. From this 10 rows, I'm asking machine learning model to look at only these 7 rows and learn from this. Okay. And after learning, after the machine learning model has learned from this, I'm going to check how this machine learning model is working. Now, if you look at these last 3 rows, machine learning model does not know about this, right? Machine learning model has no idea about this. Now, what I'm going to do, now I'm going to pass these values. I'm going to say that, okay, so now if you're spending $8.6 on TV, 2.1 on radio, and then 1 on newspaper, tell me how much sales I'm going to make. Okay. Now, after the machine learning model has predicted a value, I'm going to check if it has predicted correctly or not. That is what we are going to do. Okay. For this, I'm going to give 70% of the data to machine learning model. I'm going to ask it to learn, and then 30% of the data machine learning model will not be aware of. Okay. So here I'm going to split the data X train, comma X test, Y train, comma Y test. Okay. I'll explain you what is this X train, X test, Y train, Y test. Y train, Y test. Okay. What I'm doing here, I'm going to use this train test split. Here I'll pass X means all the independent columns and Y means all the dependent columns. Here I'm giving test underscore size is equal to 0.2. Test size 0.2 means what? It means that I'm saying 20% of the data should be used for testing and remaining 80% of the data is training data. Okay. And then here I'm going to pass a random state equal to 0. The reason I'm giving random state equal to 0 here is because I want to get the same set of data every time. Okay. So now xtrain means what? Xtrain means, as I told you, initially we are only going to give first 7 rows to the machine learning model, right? We are only going to give first 7 rows to the machine learning model. And now from in this, what we are going to do? Yes. Okay, now look at this. So now here you're looking at this first 7 rows. This is training data. Okay. Let's say that 70% of the data is for model training. Okay. So now here we are having X train, X test, and then we are having Y train and Y test. Okay. So now here, what is this X train, X test, Y train, Y test? Anybody would like to answer this? What are these? X train, X test, Y train, Y test. Anybody who has learned machine learning would like to answer this? Okay, fine. So now whenever you see train, right here, when I've written train here, it means that this is related to training data. Okay. So whenever you see train here, X train, Y train, this is related to training data. So now X underscore train means here first 7 rows are for training the data, right? X train means in this first 7 rows, you are able to see this independent column. Here, I'll put this independent column in X. You're able to see these independent columns here. This is your X train. Okay. This green part is your X train. Okay. And this Y train means this Y column in the training data. Here, I'll put Y in yellow. You're seeing this, right? This is your Y train. Okay. This is your Y train. Okay. This is your X train in the training data. This independent column, this is your X train, and Y train means in this training data, this sales column, the first 7 rows, that is your Y train. Okay, now coming to X test. Now test means testing data. Okay, now the model is not aware of this. Now you're looking at 7, 8, sorry, 8, 9, and 10 rows. This is your testing data. Model is not aware of this. Okay. And then here you're having X test, right? Now in this testing data, you're seeing these 3 independent columns, right? This is your X test. And then this is your Y test. This dependent column is your Y test. Okay. I hope it is clear to everyone. What is X train, X test, Y train, and Y test? What about others? Is it clear to everyone? Any questions? Any doubts in this? Okay. So this is your X train, X test, Y train, and Y test. So now next here, I'm going to run this code. Here we are getting error. Okay, I have given one additional underscore here. I need to remove that. Too many values to unpack. Okay. Hmm. Too many values to unpack. Expected 3. Let's let's run this again. Train test split in this X comma Y, and then test size is equal to 0.2, and then random state is equal to 0. And then here I need to put X train, comma X test, comma Y train, comma Y test. Okay, let's see now. Okay, it is working. Maybe I've made some mistake here. Okay, fine. Yeah, I think I missed something here only. Okay, right. So now after this, what we should do now from sklearn, dot linear model. I'm going to import here. I'm going to import linear regression. Okay. From sklearn.linear model, I'm going to import linear regression. I'll run this. And now using this class, I'm going to create a dictionary. Linear regression is equal to this. Now what we are going to do? Now we are going to train the model. Okay. So now how are we going to train the model? It is very simple. All we need to do is linear G linear regression dot fit. To this, we need to pass training data. As I told you, whenever you're training the model, we should give only training data. That is why here I'm passing xtrain. Xtrain means in the training data, all the independent columns, and then ytrain means in the training data, only the y column, okay, the dependent column. Okay, so I'm giving this data to the machine learning model. I'm asking it to learn from this. Now the machine, now it has been trained. Okay, now after this, what we need to do? So last time, what is the equation of the line? Y is equal to mx plus c. Now last time, what happened in this? Look at this. How many independent columns did we have in this? In this example, look at this. How many independent columns did we have? One or two? Here, total bill is the independent column, right? And this tip amount is the dependent column. In this, you're having only one independent column. But look at our example. In this, how many independent columns do we have? In this, we are having three independent columns, right? So now what is the equation of the line now? This time the equation of the line is equal to m1 multiplied by tv. Now tv is going to have one m value multiplied by tv, m1 multiplied by tv multiplied by m2 multiplied by radio multiplied by m3 multiplied by radio. Okay, m1 multiplied by tv, here you should actually have plus m1 multiplied by tv. Now this time we are going to have three m values, m2 multiplied by radio plus m3 multiplied by newspaper. Okay. Now here we are going to get three m values. Now you must be thinking that if you want to get the sales, okay, this is what you need to do. Here, if you want to get the sales, this is what you need to do. Now you must be thinking that should we manually calculate m1, m2 and m3 like how we have done the last time? No, you don't have to do that. Okay, so now here we are having inbuilt functionalities. All you need to do here is linear regression dot intercept. When I did linear regression dot intercept, you're looking at the C value, right? You're going to get that C value. Here I'm getting 2.994. This is your C value. Okay. And now if you want to get M1, M2 and M3 values, what you should do, all you need to do here is linear regression dot coefficient underscore. Okay. Now when I run this, okay, I made a spelling mistake, coefficient underscore. Now when I do this, in this array, you're getting these three values, right? This first one is M1, second one is M2, and third one is M3. Okay. So now let's substitute this. So now I want to know that here, let's do this calculation. Now what I'm going to do here, the equation of the line is this, right? This is the equation of the line. We already know C value. C value is how much? C value is 2.994. I'm going to put that here. And what is M1 value? M1 value is this. And what is M2 value? M2 value is this. And what is M3 value? M3 value is this. Okay. So now let's make a prediction. Now here, look at this. In this, what is happening? On TV, we are spending this much. On radio, we are spending this. And on newspaper, we are spending this much. Okay. So now let's put these values in that equation and let's see how much sales amount we are going to get. Here, I'm going to pass 8.7 here, 8.7, and radio. Here, I'm going to pass 48.9. Let's pass 48.9. And newspaper, I'm going to pass 75. Here, I'll pass 75. Okay. So now do this calculation and tell me how much are we getting. Here, sales amount. Let's see how much sales we'll get. Okay, we are almost done. Last 10 minutes. Can you guys quickly do this calculation and tell me how much we are getting? Here, 0.0445 multiplied by 8.7. Here it is 0.387 plus next is 0.1964 multiplied by 48.9. How much are we getting? 9.603. 9.603 plus this one minus 0. minus 0.0027 multiplied by 75. How much are we getting? We are getting minus 0.20. Okay, plus 2.994. Okay, if you do this, how much are we getting? 0.387 plus 9.603. Here, how much are we getting? We are getting 9.99. Okay. Here it is 9.99. Okay. And then here you're having minus 9.99 minus 0.20. Here you are getting 9.79 plus 2.99. Here you are getting 12 point sales is how much sales we are getting? 12.7. We are getting sales 12.78. Okay, let's see how much is the actual sales. How much is the actual sales for these values? Here, the actual sales amount is 7.2. So now what do we understand by looking at this? So obviously here it is making some error, right? It is making some error. So every time what happens, it is not going to predict the exact value. Okay, it is going to make some mistake here and there. So now on average, how much mistake it is making? How do we know that? So now let's find out how do we know that. So here we have done this, right? We have done this calculation here. Here this error. Okay, like this here we have calculated this error. Okay, so this is called as mean squared error. Okay, this 5.4 here we are getting, right? This is mean squared error. So now let's find out how much is the mean squared error. On average, how much mistake you are making. So for that, what we should do before this, we are having, I need to import from sklearn.matrix. Here I'm going to import mean squared error. I'm going to import mean squared error. Okay, and here I'm going to call this mean squared error. And now to this mean squared error, what we need to do, Now the machine learning model has no idea about the testing data, right? That 20% of the data is for testing, right? So whenever you're finding mean squared error, you should pass the test data. Here we are going to pass y test, comma, y. Here I need to pass y pred. We did not find out predictions. So now if you want to check what all predictions this linear regression model is making, here I'm going to have y x test. So now this is your testing data. So now in the testing data, this is the 20% of the data which your model is not aware of. X test means the independent columns. And here y test dot head, this is the correct answers for X test. Okay. So now if you want to make predictions, what you need to do, here I need to have linear regression dot predict. Here in this, if you're passing X test, what this predict method is going to do, it is going to give you all the answers of y test. Okay. So here, when I do y test, y underscore test, I'll run this. So now y test dot head. So now when I do this, the first answer is 11.3. But what the model is predicting, it is predicting 10.057, which is close. Second time here, the answer is 8.4. But the model is predicting 7.45, which is again very close. All the predictions, I'm going to store all the predictions inside ypred. Okay. So now these are the predictions which the model is making for the testing data. I'm going to store it inside ypred. I'll store it inside this. And now here I'll find out the mean squared error. Okay, now when I'm running this, let's see how much is the mean squared error. Here mean squared error is 4.402. Okay, and now because we have squared this every time, now we should find out the root mean squared error. How will you find out root mean squared error? Here I'll store this 4.402 inside mean squared error variable. And now I want to find out root mean squared error. So here all I need to do is np dot sqrt. Np is nothing but numpy. So this when you're passing root mean squared error is 0.09. Okay, it is nothing but I'm finding I'm putting root to that 4 point something value. Here I'm getting root mean squared error value is 2.098. Okay, this is what is happening. So now to this predict, if I pass some different values, where is that predict? Here to this linear regression dot predict, if I pass some different values, let's see if this time it will give me correct answer or not. So what I'm going to do, I'm going to pass some values to that predict. Okay, here to this linear regression dot predict, let's pass these values and see how much prediction it is going to make. Here to this, I'll pass radio. On radio, we are spending 8.6, 8.6 comma, and sorry, on TV, we are spending 8.6. On radio, we are spending 2.1. And on newspaper, we are spending 1. So we should get 4.8. Let's see if you are getting 4.8 or not. Let's see the prediction. Let's pass this like this. Okay, here look at this. How much it is predicting? You need to pass this in the form of 2D array. Look at this here. The prediction is 3.7. What is the correct answer? The correct answer is 4.8. It is making some mistake. Okay, so guys, this is how linear regression works. Is this clear to everyone? How does linear regression works and how do you create a machine learning model using linear regression? Any questions, any doubts in this you guys have? Okay. Guys, I hope you got an idea of what is linear regression. Okay, what exactly you need to do in machine learning. I'm hoping I'm hoping that you guys got at least some knowledge on this. Okay. Now you guys can ask me your questions if you're having any questions on machine learning. Whatever doubts you have, you can ask me.